to spend 4 months trying to teach you how to work the copying machine, right? Like, you can learn, right? You're capable of learning things. The person without the degree may be better than this person in terms of a better employee, but I don't have anything that shows me that. Maybe they filled out their resume and I can read, you know, oh, they done this, but the degree actually is a certificate of basically showing your ability to learn. Does that make sense? Okay, so a lot of the ways that I'm going to approach things in here is as processes. Like, can I teach you a process? And can you retain that process? And then when I give you a problem, can you execute that process? If you can do that, then that means that you're capable of learning processes. You may never have to graph a parabola ever again in your life. But what you have demonstrated is that you can follow an 8-step procedure without having to go bring out, you know, reference or call someone or Google. I mean, you can do it. Like, your neurons in your brain, they function that way. Does that make sense? Okay? All right. So that's kind of my best answer to why we're doing this. I hope that helps. Yeah. All right? Okay. Now, 15 minutes. Let's see what we can do in terms of fractions in 15 minutes. I hate these boards. They just put up these boards, but for some reason my mouse just does not pick up on this board. So, all right, so here's the packet. So the way the packet's laid out, this is, remember I told you there's 2 math classes, right? People going on, people not going on. So you're in the not going on group. What the packet is all about, trying to make you not have to pay $150 for a book that you're going to use for one class, and that, you know, it's over. So this packet was made by faculty members here, not me, but it is not designed to be a place that you go to learn math. It's just basically problems. And what I'm going to do is, in class, I'm going to go through and kind of say, okay, we're going to talk about multiplying and dividing fractions. Here's the procedure, here's the process. Now let's do some examples, all right? And that's pretty much the way the whole thing's going to work. So if you miss class, you can't go read the packet to learn what you missed. It's not like a textbook, all right? Not like you could read a textbook anyway. That's hard enough. So let's talk about multiplying and dividing fractions, and then adding and subtracting fractions. Let's get those out of the way. So when it comes to, do you remember when you were in grade school learning your first basic arithmetic, you know, with numbers? Did you learn multiplication, division first, or did you learn addition and subtraction first? You learn addition and subtraction first. But when we talk about fractions, we always start with multiplication and division first. Now let's talk about why. So multiplying and dividing fractions. All right, so let's first make sure we understand what fractions are. So if I write 3 over 4 like that, everyone understands that's 3 out of 4 parts. So if you take something, break it into 4 pieces, we're talking about 3 of those 4 pieces. That would be 3/4. This is called a proper fraction. Okay, it's called a proper fraction. Okay, so what if I flip it over and I make it that 4 over 3? So this is called an improper fraction because the number on top is bigger than or equal to the bottom one. So that would be like, okay, you take something, you cut it into 4 pieces. I'm sorry, not 3 pieces, right? You take 3 pieces, something cut it in 3 pieces, and you take 4 of them. So it's like 1, 2, 3, and then you would have to have an additional one over here, right? So it's improper because the top's bigger than the bottom. That's just, I'm trying to get you to understand some terminology. Improper fraction. And then what about this one? Y'all seen that before? That's called a mixed number. So this means 1 and also 1/3. So that's like you have a whole chocolate bar, let's say. It says you have like 1 whole bar plus 1/3 of it. So it's like you have the whole bar plus 1/3 of a whole bar, right? But that is actually the same as this one, isn't it? Yes. Because that was saying I take a bar, cut it into 3 pieces, take all four of those, right? So I would need another piece of it here, right? So aren't these the same, like visually? So this and this are the same. So do you all know how we get from a mixed number to here? There's like a quick little thing you do. You take that number, multiply it times that number. So what's 1 times 3? 3. Then you add 1, which gives you 4. So you write down 4. And then you put it over 3. How many of you have seen that, converting a mixed number to an improper fraction? Let's do one more just to make sure. So if I want to convert 2 and 1/4 over to, from a mixed number into an improper fraction, what would I do? 2 times 4, 8, add 1, 9 over, always that number, 4. So 9/4, 9 over 4 is the same as 2 and 1/4. How do we go from here to here? Like from here to here, I think we've got it. Here back, you have to do this thing. You have to do 9 here, 4 here, and then start, 4 goes in there how many times? 2, right? Then you put an 8 here. 2 times 4 is 8. Subtract, you get 1 left over. That's your remainder. So you put 1 here and then over the divisor, which is 4. So that's how you get from an improper back to a mixed. Okay, we got that out of the way. Let's talk about multiplying and dividing. So if somebody gives you 2 fractions, okay, I'm going to do this in general. We're going to talk about multiplying first. Let's say I have a fraction, a over b, and I tell you to multiply it by another fraction, c over d. So underneath this, I'll do an example. Let's say I have 1/3 times 4/7. So how do we multiply 2 fractions? Just multiply to get a common? That's addition and subtraction. So that's why, and that's harder to do. And that's why we do the multiplication first. Because this is the easier thing to have to do. When you multiply 2 fractions, all you do is just go straight across. Okay? Just multiply straight across. So in terms of a general formula, this would mean I take A and multiply it times C. And then on the bottom, I do B times D. Right? So that's kind of a generic formula. This particular example, this means it would be 1 times 4 on top over 3 times 7 on the bottom. 1 times 4 is 4, and 3 times 7 is 21, right? 4 over 21. Does that make sense? Okay, now, because this is an algebra class, we are going to start moving away from this as a multiplication symbol. Because later on we're going to be using the letter x as a variable. So this notation becomes kind of too basic for us. And so we replace the x with a what? A dot. Okay? So you'll see me put a dot here instead of these x's, but just understand that those dots mean multiplication. All right? All right, so that's multiplication, just straight across. So let me give you another example. How about 2 2/5 times 3 1/4? Sylvia? Where's Sylvia? Sylvia? I'm kind of throwing a curve. Like these, the 2? So you want to multiply the 2 and the 3 together? Is that what you're... No? No? Yeah? Okay, so look, let me ask you something, Sylvia. You understand this, right? So if those looked like this, you could just go straight across, right? So why don't you make those look like these? So why don't you switch this into it's improper and that to improper and then just use the rule? Make sense? Okay. So Sylvia, if I was going to do this one, what would that mixed number be converted to an improper fraction? 12 over 5. Everyone good with that? And then times, and then this one right here? 13 over 4. Okay, good. Everyone on board? Now at this point, we could just go straight across. Yes? I'm going to do that, but then we're going to back up and look at it again, and there's something else we could do. So let's just use the rule now. 12 times 13. 166? 56. Over 20. And we could box this as our answer, but it would not be completely correct because it's not reduced. And what I mean by reduced is this. Like if I write 4 over 8, that's the same as what fraction? You could write that as 2 over 4, but that's still 1/2. So what you try and do is get it completely reduced down to its lowest terms. And what that means, you're trying to get rid of any common multiples, canceling them out. So let's say we were at this point right here. We would have to realize at this point that there is a number that goes into both of these, right? And what number goes into both?
7.
What number would go into both? Just like over here, 4 over 8, you say what number goes into both 4 and 8? 2, right? So 2 goes into 2 twice, 2 goes into 8 4 times. Then you would say it again. What number goes into both of these? 2 and 2, right? 2 goes in there once, 2 goes in there twice. You're trying to figure out what numbers go into these two. What number goes into both of these?
4.
4 does. Now that's hard to see here for a lot of people, right? That 4 goes into both of these. Now let's just do it. How many times does 4 go into this? 5 times. And how many times does 4 go into that? What is it? 39 times. So that might not be easy for people to see. Do you all agree? So back here, at this step, you can cancel or reduce things across the numerator and denominators here. So do you see a number that goes into, let's say, 12? Down here, does 5 or 4 go into 12? 4 goes into 12, right? How many times? 3 times. So I could reduce this fraction. I could say 4 goes in there 3 times, 4 goes in there 1 time. You see how I did that? And then do it for the 5. Does 5 go into 13? It does not, right? So at this point, I'm left with a 3 here, a 13 here, a 5 here, and a 1 here. So now go straight across again. What would happen if you multiply straight across? You would have got that 39, and then over here, 5 times 1, you would have got that 5. You all see what I'm saying? So if I were asked to multiply fractions, I would always try and reduce them before I multiply straight across. It just makes life easier. Here in the first problem I gave us, we didn't have to worry about that because our final answer was reduced. There is no number that goes into both 4 and 21. All right. Yeah, we didn't get through a whole lot today. So we're already going to not have homework tonight. All right. So, but I suggest that you at least go through, get your materials together. We'll pick up next class, and we'll get caught up. Don't worry. But come in ready. We'll hit the ground running next class. All right. Everyone have a good day. I'm going to pass out a sign-in sheet next class. All right. I forgot to do it today, but I've got your little sticks. I'll take attendance off the sticks. All right, see you. Have a good day.
So about my stick, Frank is my nickname.
Okay.
My name will be Frank Heskey. You see it like on the roster.
Oh, on the roster. Okay. Okay, cool.
And then about the calculator, you said that we're going to be doing like graphing.
No, we're not doing graphing. I don't know what he was talking about. The one I showed you is the one, this one right here is the one I recommend you get. Yeah. Yes, sir.
So you said we need that packet of questions, correct?
You'll need to get it. You can print it offline or you can go to the bookstore.
The bookstore, they have it?
They have it like $5. Yeah. But there's no homework out of it tonight. But starting next class,